Good afternoon, I am Mr. Ish. We are looking here at properties of radicals. Not a difficult video by any means, but an important one because radicals and their properties are frequently employed in algebra. What are some of the main important techniques? How about this? Root A divided by root B can be written under a single radical. That fraction can be employed and brought in under a single radical. Consider this: root 2 divided by root 3 can be very well under a single radical. You have 2 over 3. That's a very good property to be aware of. Another very useful one is root A times root B is equal to root AB, where AB, the product, is under a single radical. Consider this again: root 2 times root 3 is equal to root 6. Very useful property. These ones which I'm identifying. And how about this? An nth root A times an nth root B would be nth root AB. Relatively similar to what you're seeing here. You're seeing something like cube root of 2 times cube root of 4 would be similar to you saying cube root of 8. But then of course you can simplify this. Cube root of 8 is really just a 2 because 8 was really a 2 cube, and then you're doing a cube root of that and you will easily get that 2. So this here is another useful property to be aware of. With regards to this property over here, of course, these values n are called an index of the radical. If they are similar, if these index values are similar, you can combine them better, because when you're looking at variables, here you're looking at numbers, when you're looking at variables, that property comes in quite handy. Anytime you're looking like something like, let's just use a proper variable here, cube root x, and you're multiplying that with the fourth root y. You know you got two different indexes over here, so you can't really do the combination. But if you do cube root x and you multiply here with the cube root of another x, you have same radicals. This could even have been an xy over here, would not matter here. Then you could do cube root of x squared y, and this here would be a better version than that. This here would be a combined product of what you're seeing over here. Here you can't really do much with this with regards to combining them, because these index of these radicals are different. So that right there creates a conundrum for you all. Let's look here at our first question. We have this expression over here. We have to simplify. Always work from inside out, especially when you have parentheses involved. Root 2 times 3 would be nothing other than just you saying 3 root 2. You couldn't really combine it in the true sense. And then you have a root 5 here in the denominator. You can combine this numerator. Root 3 and root 2 is no different than that property. Root A times root B is root AB. Here you'll get 3 root 6 in the numerator, and you'll get root 5 over here. You can look at this: root A divided by root B. Under a single radical you have A over B. You can rewrite this as 3, and then you can have a 6 over 5, and you can have that. And right there is your final answer. If you didn't want to convert this into this, you don't have to, but this right here is the final answer, which demonstrates the employment of those radical properties I was talking about. Let's look at this question. We have an expression over here: cube root x plus 1 divided by cube root y under this whole exponent 2. Combine everything here within this square brackets into a single radical, because you can. It's x plus 1 over y. Remember, root A over root B is all under a single radical, A over B, and then we have this little 2 sitting out. We can easily open that up. This x plus 1 over y can be rewritten as this, to the power of 1 over 3. Let me talk about this specific property over here, which I didn't mention earlier, but I will now. A to the power of m over n, a fraction exponent, is the same thing as n root a to the m. This numerator of this fraction serves as the exponent of your base. This right here is my base A. The denominator of that fraction serves as the index. And that's exactly what we're seeing over here. This right here, 3, is really 3 over 1, right? 3 over 1. You can bring that out as 1 over 3. X plus 1 to the power of 1, cube root 3. And you're seeing that, and then we have this 2 sitting outside. Your answer is x plus 1 over y to the power of 2 over 3, and this question has been completed. Let's look over here. Just a little extra time we'll spend right over here. 4 to the power of 3 over 2. If you want to write that in a radical form, you're really looking at 4 cube and then square root. By default, a square root always has a hidden 2. You don't have to write that 2, because a square root means the 2. The denominator over here indicates the index over here, which is a 2, a square root. And you're looking at this. This right here has been converted into that form, which will be the square root of 64, and you know that will be 8. Let's do a little one extra exercise step over here for a different question, and let me show you what that will be. 3 to the power of 4 over 5, and then we're looking at that to the power of 2. 3 to the power of 4 or 5 can be no different than you doing 3 to the 4th to the 5th root. A to the m over n. The denominator becomes your index, the exponent numerator stays as your numerator here, but within the radical, we're looking at all of this to the power of 2. You don't have to convert this back, I'm just doing it for the purposes of this video. 3 to the power of 4 is really an 81. 81 to the 5th root, and you have a 2 sitting outside. This is no different than you saying 81 to the power of 2 over 5. And there's nothing more you could do with this, and this question here would stand as is. 81 to the power of 2 or 5, you can either write it in this form or you can write it in this form. Now let's look at this, and this let this be our last little extra question we're doing. Work from the inside out. 27 to the 3 over 4 is no different than you saying 27 to the cube and to the 4th root. That's all what it is. But unlike such a big number over here, I know 27 is 3 cube. And then I really have a cube sitting out here to the 4th root. 3 times 3, 9. This is really 3 to the 9 to the 4th root. Alright, all of this has been converted into that. But now we know we have it sitting within a radical. I've converted all of this into this 4th root 3 to the 9. That's what I've done. I've just transferred this over there. This you can say as 3 to the 9 over 4 and to the root, which is the same thing as 3 to the 9 over 4 to the 1 over 2, because a fraction exponent indicates a radical is coming into play. That right there you can say is 3 to the 9 over 8. See, 9 over 4 times 1 over 2 is 9 over 8. And you can, if you want, write this as 8th root of 3 to the 9. If you want to bring a calculator and present a value for 3 to the 9, it would be this. Your answer would be, final answer would be 8th root of this 19683, and that right there would be your final answer, and we'll make this into a good little index. 8th root of 19,683, and that right there is your final answer. With that, I bid everyone farewell. Thank you for watching. Have a nice day.